Hello, this is U-matic video equipment. It's an old professional video format, and to get the very best results from this you really need to connect your U-matic machine, such as this one, to a digital time-based corrector like these two, with a dub connection which separates the luma and chroma signals. It's similar in function but different in operation to the S-video connector you might have seen on so much domestic equipment, better domestic equipment. Now, these digital time-based correctors that support this dub signal are exquisitely hard to get hold of. What this will then do is convert from that dub to more modern signals like S-video or YUV that you can then digitize to get the very best from U-matic. If you don't do that, the results really are not particularly good. So what I need is to connect from this dub out here to dub in here, and you also actually need another cable as well, which we'll talk about later. But a big problem is that these dub cables are extremely hard to source. I don't know where I can get some of those. I've got a couple in use in the studio already, but I've got more equipment that I can't hook up because I don't have any of those dub cables. You can't even make them up because the connectors are unobtainable now. There was a supplier who was making them when those cables could be, those plugs could be obtained, but they've all gone. So a major problem there. Oh, you're expecting somebody to just say special delivery and hand me some dub cables, are you? Well, that's not going to happen.
Special delivery.
Oh. This doesn't contain dub cables. They wouldn't fit in this little packet. But let's see if there's something here that might help. I was having a conversation with a subscriber, Paddy Linus, who is also looking to solve this problem with dub cables. And he was wondering whether you could get some of the plugs that of the correct type. They're called Hirose connectors, and he thought he might be able to source one end of the connectors but not the other. And I was thinking, well, what about maybe using the connector on the panel of a scrap machine? At least the center part of that should be correct, though the outer fitting is incorrect. So we had a bit of a conversation about that, and he sent me some goodies. So here are the connectors. So effectively we're going to make a cable to go from there to there, because we're going in to this and out from a video recorder, which will have this type. And you couldn't just connect these two together because they both have the spigots on them for connecting the outer rotating part of like a BNC connector. But the middle part is right. So anyway, let's see what we have in here. He's also sent me, which is really handy, a set of feet. These are like the Sony feet that are used for U-matic video recorders. Also, I think probably be the same ones as on Betacam, complete with a set of screws. So they'll come in handy because I have various machines which have been used in racks and have lost their feet. So that's handy, but that's not what we're working on today. We have two of these Hirose connectors. Is that HRS? Is that Hirose? And they are the ones with the pins. So that will connect directly to the video recorder end. Let's just pop that out. So that's a lot of the problem solved right there. Halfway there, right there. So that will connect to the video recorder end. And obviously need to make up the cables to go with it. And I was wondering about using a socket from a scrap video recorder, but he's actually got a brand new socket here. Seems criminal to chop this up, but it needs must. Right, so that is the end that that's connecting to. And we have another of the one with the pins, the male connector. So the question is, could we take the middle out of this and fit it in here? That looks non-trivial, doesn't it? But that is our challenge, because we can't get these plugs with the female connector on. Right, Let's take a look at what we're trying to do. Shall I have a look under a microscope at what we have here? So there you can see the Hirose logo, and the pins are nicely numbered. That's good. Right, we can see a notch in the outer shell where the top two pins are, and it looks like 16, but I think that's actually 1 and 6, and then all the rest of the pins are nicely numbered. So that's the one we do have, the plug with the pins. Let's have a look at the chassis mount socket. So there's a pin that goes into the notch by pins 1 and 6, and there is our socket, which is sitting in this housing, which is our problem. We need to get it out of the housing so that we can mount it in the other cable, end of the cable. So that's going to be our challenge, isn't it? How are we going to separate this from its housing? And it's a terrible crime to chop this up, but unfortunately that's what we have to do. Just looking at the back here, this is where the solder side is. So this is a brand new chassis mount socket. Let's dismantle this and look inside at the construction in here. Right, using my iFixit kit, I think it's a 1.3mm hex drive to dismantle this shell. And there is the back of the cable plug. So we would have to take that middle out of one of these and fit this part. That looks very hard. Something that I've noticed here, looking at the panel socket here versus the plug here, which is the cabled plug, looking at the back of them, you know, the connector part does seem remarkably similar. Starting with the panel mount socket, what would I need to do to release this plastic? I could cut the body along here and maybe opposite and have the two halves split apart, but I wonder if that's necessary, because maybe I really need to fold this metal out. How do you think this has been inserted? Do you think it went in from this side or from this side? What should I cut? Is this notch telling us something here? Or is that just for orientation? No, I think that's just orientation. So how was it inserted? And how could I take it out again? I'd like to do so without taking to a Dremel or something. Well, I don't possess a Dremel, some kind of cutting device. I wonder if I can release something and allow the whole body to slide out. Is there a clip down there? So I'm going to have to experiment and push and pull and see if I can work out how to slide this body out of here and doing the least possible damage. I'm thinking that since this has to be able to take pressure that way, I'm thinking they fitted it this way, and then this shaped metal here is such that it locks onto a ridge in the plastic, and so I'm thinking the way to get it out is to push it that way. I may be wrong, but what I'm inclined to do then is to use this. This is a what size socket? 7mm socket, which just sits nicely over the pins and allows me to apply pressure to the plastic housing. So I'm going to put that in a small bench vise and do it up. There's a little bit of clearance between the front face and the metal here. Might give me just enough clearance that I can start pushing the plastic fitting out that way. Let's give it a whirl. So I'm just going to watch it and see if when I do this up, if that plastic starts to move. That's not working. In fact, the plastic is starting to spread out over the top. So that is not the way to release it. It's actually making it jam in even harder. So that did not release it at all. Maybe I need to go that way. So what I need to do then is support the body here with some kind of fitting, maybe of the same size as this thread, and apply that to the front face and push that way. Okay, so suppose I support the body front face like that. Sorry, this is the back face. Support that with a large, what size is that? 11mm socket. And now put the smaller one on that face and compress that up. Will the body go that way? Not sure my vice is big enough. No, my small vice is not going to do that. And what seems to have happened, to my surprise, is it's split in two. So that's obviously the way this is constructed. I wasn't expecting that. So the pins fit through here, and there's the other part of this body. So I still have to push this out, I think, and we're going to have all this to do on the cable connector as well, which is going to be a lot scarier because I don't want to crush the pins really. But one thing at a time. Yeah, I'm not sure I'm going to do it with this one. That's going to be even harder. But should I continue, do you think, and push out the rest of this body? Or do I assume that that is common between the two connectors? And what I actually need to do is the same process here and then push this through there. So the question there is this part identical between these two? I don't think it is. No. So I need to carry on and push the rest of this out, and then the whole of this needs to be fitted in here. So let's see if we can push out the rest of that plastic housing. Okay, let's see where we're up to. It's continuing to push through, but it's not like it's suddenly going to go out and fall out. Partly perhaps because my socket here is possibly preventing this metal from expanding outwards. I think it is. Yeah, that's definitely the problem. I can see markings on here which correspond to the socket set. So this is just a little bit tight. I could try a bigger socket that may be able to fit over the whole of this outer edge. Let's try that. Alright, let's try that then. So it'll be sitting on there. Okay, these are M6 nuts I've got here. I'll have to use two of them now. Or maybe a second washer. That might be better. Something just happened, but I don't know what. It's continuing to push through. I'll use yet another washer. It just feels like it should suddenly pop through. And it has done. Okay, so I've taken the whole of that body off there, so I can now refit this on here. Now that'll take a little bit of fiddling. I've got to refit that on there, and then that's phase one of the job done. Well, I'm quite pleased the way that's gone. So there was the chassis mount socket, and we've pressed out of it the entire socket assembly with all the pins, and this is kind of two parts, this. Okay, so now the only thing we have to do, well, two things really. So what we have to do now is, this is a cabled plug, this is going to be one end, this is the other. I need to find a way to press this out. Now I know it's going to be discarded, but I still don't want to smash it up if I'm going to avoid it. Press this set of pins and its body out, and then see how I'm going to mount that in there. Right, not quite sure how I'm going to do that. How would I get this out? Well, perhaps if I can heat it up, the plastic will become a bit softer and I may be able to dig it out. So I think I'm going to use hot air gun to heat this, see if I can split this, then I can take all the pins out, and then I should be able to push hard with some object that will fit inside there and get the rest of the housing out. Right, so this is the tricky bit really. Remove this by heating it and pulling on something. Let's see what we can do. Okay, right. We have a really nice view then of the connector. We're trying to remove this top part. There's a couple of little notches we can, well, not quite see from this angle, but there's one, there's the other, and I'll need to insert some tool into them when it's heated up. So perhaps I should have such a tool ready now. I mean, there is this pick, but I think it's too small and fragile. That's not going to get me any leverage. I need some kind of screwdriver to stick in there. Or blade, maybe? Okay, maybe blade, but I'm going to have to get it pretty hot, I think. It's going to be tricky, but let's see what we can do. So I'm going for 200 Celsius, so that's going to be fairly warm. Of course, all this metal is going to act as a great big heat sink. This is where we have a good advantage, by the way, with this microscope, that we have a Barlow lens on the microscope, which gives you a better working distance. The lens is up here, you can't even see it on that shot. Let me set you up. So the microscope lens is, way up here, and we're looking down on this. We've got plenty of working room. I covered this microscope when I bought it a few years ago now. Well, the matte plastic is just starting to deform, really. I'm getting quite hot fingers doing this game. I may have to stop with the hot air in a minute. Okay, so up until this point what I've been doing has been reasonably non-destructive, and this is very destructive. I could try knocking it through if it's really loose, just with a screwdriver. Don't think that's... If I had a bit of small metal pipe to hand, I could fit it over the centre pin and then press it, but I don't have anything, I don't think, of the right sort of size. Maybe I could press that in and have the bottom pop out. Do the old socket set trick again. That might work. I could try pressing that through there. So I've got a socket on the back and a standoff on the front. Put a nut on the standoff to deliver the energy more cleanly. It sort of went in for a while, then seemed to stop. Keep trying, I guess. Yeah, I don't want to overload the collar, so I'll find a different, because I'm putting this on there, and so all the pressure's being delivered to the collar in a direction it's not supposed to take, I think. So I'll find a smaller socket that sits on here, so that'll sit on those threads a bit. So what we're looking for is that nut there to start going into the body. I wonder if some more heat might help now. It is helping because I can hear the creaking of the vice as it's doing up slowly. think it's worked. It might be a bit hot to touch for a moment. Right, separate these off again. Right. Let's see where we are. Well, it's working, but I've got to go further. Just keep going. I'm not sure I need any more heat now. It's pushing right through now. Okay. Success. We've pushed out this component completely, and actually it's still in remarkably good working order. That I don't think anything's actually chewed up there. And we now have this body into which maybe we can insert the female connector set. So here's the female connector set, and remember between pins 1 and 6 the markings have been damaged, I think, between 1 and 6. That needs to be where the notch is, so it needs to be like that, only this needs to be pushed all the way in so that the front face of that is almost level with the front of the socket. How am I going to do that? Just push it in? I could certainly start by pushing just with the vise. If I take the back part away and all the pins and just cleanly push that in with a vise, I can do that, can't I? But I need to be super careful to get the orientation right. That's the socket, and you can see that the notch is right between pins 1 and 6. And our notch is between pins 1 and 6, so there's nothing wrong there. Anyway, you couldn't go far wrong. So I can push that in, but I'm going to struggle to get it all the way in. But let's just make a start with that. Okay, well that was pretty easy, that side of it. We need to go further, but I could use a socket or something to just push gently on there and take it through to the front. Not too far though. It's pretty much sloppy, falling around now. Oh no, it's sat on the front edge here. Yep, that's just sat there. So if I now assemble the back part with the pins, perhaps all I need to do at the end is glue it. Yes, we're there. We just need to push that home the rest of the way without damaging the pins. Fiddly, but must be doable. Yes, that's all we need to do. All we need to do, somehow, is push that plastic housing into place without damaging the pins. Perhaps I could use this to help me. If I split this, maybe I can sit it on there, because it'll have all the right holes drilled in it for the pins, but this, I don't know if I can take it apart. Yep, I can take it apart. So if I take this apart, I'll borrow this plastic component just to help me push this home. It's not ideal, but it might just do. Almost there, but there's a bit of slack because this is not yet fully placed as far in as it needs to go. There's a spigot on the part that I've raided off the other connector, which is on the one hand slightly in the way, and the other hand is actually sort of helping. It sort of worked, but the terminals are able to slide back too far. So I kind of need something round that I can sit just on there. Maybe a socket will fit. Yes, okay. What are we using? 8mm socket. Let's give that a go. So what I'm hoping to see is this plastic sink in here slightly. I think that's fully pressed in. It's not going to go any further. So we just have the problem that the solder terminals are... Do you know what? They're not slopping about so much anymore. They are pretty much there. Maybe I'll drive it just a tiny bit further with this. They seem pretty stable. That looks pretty good. Let's see if it will mate with the connector on the time-based corrector. Here's the connector that this needs to fit onto. Notches at the bottom, pins at the bottom. That looks absolutely perfect. We've made the elusive Hirose connector. How about that? So I could feel extremely smug that I have created the elusive dub connector, but I'd better not get too overjoyed just yet because I've made a mistake. The pinout is such that either side of this notch is pins 1 and 6, but when we go to the other side, following through from that notch, we come over to here and we'll find that it's marked 1 and 6 over here because I've got a notch over here. So somehow we've moved from the notch being at this point to rotating around here. So I am one set of pins out. Now it doesn't matter, it'll work just fine, but it means that the pin numberings on here are incorrect. So what do I do? It seems to me I have three options. Either I just ignore the problem, but that could cause confusion when it comes to wiring up the cable, or I take it all apart and see if I can fix that, but I'm not sure I can because I think this notch lines up with something with a spigot inside the housing, so I'm not sure I can fix it. So the third solution, I think, is to get the sharp blade and erase the numbers from the back of this plastic and just make sure that I follow the numbers that are on the front here. So that's what I'm going to do. The other thing is I need to work out what the pinout is. Now I know roughly that the pinout has got dub on 1 and 2, chroma on 5 and 6. There's a dub mode, which is pin 7, the one in the middle. Not sure about 3 and 4 because I'm just referring to the wiring on some video recorders to find out what the connectors are. But it may be that not all video recorders, and possibly the one that these diagrams were lifted from, uses these signals because there's different chroma frequencies. This is chroma dub 685 kilohertz, and there's another frequency. So it might be that these cables are used in some machines. So the only way to be sure is to check the wiring on a real dub connector. This is a real dub cable here. This is what I'm trying to replicate, although not quite this long. So there's every possibility that pins in 3 and 4 are used here. So we'll check them with a meter in a minute. First thing I'm going to do is erase the numbers from here because they're all shifted one, with the exception number 7, which is correct anyway. So just pointing out what the problem is again, maybe it's a little bit clearer to see now. So we have this notch and pins, they should go 1 and 2 across there. Sorry, you should go 1 and 6 there, there's 2, 7, 5, what have you. So these are definitely correct. They are exactly the same as on this connector here. Let's have a look at real dub cable. So here's the real dub cable, and you can just about see the pin numbers 1, 6, 2, 7, 5, 3, 4. So that is correct on that side. You can just about see number 1 there. But following through to the back, the notch disappears from that point and reappears over here. So for whatever reason, that slot is in a different place, and therefore the numbers ended up in the wrong place. So this is the real pin 1 here, and that's 6. So I'll erase these numbers here. Maybe I can do that better when I make up some more of these, if I do make up some more of these in the future. So looking at the connector, we've got 1, 6, 2, 5, 7, 3 and 4. And we know 1 and 2 are used for the dub, the dub Y, that's the luminance. So that's 1 and 2, so expecting to see those two connected. And then 5 and 6 are the dub chroma, so expecting to see those two connected. And the screen is the second one there, and the screen is the second one there. Pin 7, we're expecting to see a straight through signal, that's a mode signal. And then the question is whether 3 and 4 are connected, and if they are, which is the screen? And I won't know really. That could be a little bit tricky, but let's just see if they're connected at all. So let's start with pin 1, which is there. Where does pin 1 arrive on this connector? On the other side. So that's pin 1 there, not that side, so they're reflected across. There's pin 1 there. So the next one down will be pin 2. So that's pin 2. Similarly, 6 up there will be this top one. And next down is 5. Right, now my question is 3 and 4 at the bottom. Oh, let's just do number 7, confirm that that's linked through. Yeah, right. So going to the bottom, I bet they are wired through. Here goes. Yes, they are wired through, so I need to connect those up as well when I build the cable. But my problem is I don't know of 3 and 4 which is signal and which is ground. How am I going to work that out? Well, maybe the time-based corrector will help. Maybe I can see if there's a common ground. I reckon there's a common ground between two, well, there might be a common ground between 2 and 6. Okay, I'm seeing about, I think I had about 2 ohms between 2 and 6, which says that the dub, chroma and luma signals have a common ground. That being the case, is that also common? It should be common to one of the ones pit 3 and 4. It's not. Okay, I'm just going to compare it to the chassis then. So pin 2 is connected to chassis because it's dub screen, and pin 6 is connected to chassis because it's chroma screen. Are pins 3 or 4 connected to chassis? No. No. In fact, they may not be connected to anything on this machine. So that leaves us with the question, should I connect up pins 3 and 4? And if so, should it be screened? And if so, which is ground? And I just don't have that information. But it looks as though if I'm making up dub cables for use with this TBC, pins 3 and 4 probably don't need to be connected at all. Now you might say, why don't I take one of these plugs apart and have a look at the wiring inside? And actually, off camera, I tried to do that very thing, and it seems that this moulding goes into the body, and even when I take this screw out and take these clamps off, I can't actually get the plug apart, and I'm not risking breaking the cable. So we'll just have to wire it as best we can. So we'll do the 75 ohm cables on those plus pin 7. Right, I need that cable, that 75 ohm cable. I haven't got any of the right sort of thickness in today. So great that it is that we now have the proper dub connectors. What we really want to see, of course, is a finished dub cable. Stupidly though, I ordered the coaxial 75 ohm coax cable from a USA supplier. So no wonder it's not arrived yet. But anyway, this video is long enough now. So what I'm going to do is wire this up and demonstrate it working as a YouTube short, and that short will then link back to this main video. Okay, I'll do plenty more content on audio and video technology in the near future, including revisiting the SVC, SVR Grundig format, because there was a lot of interest in my working on a second machine for that. So that will be done shortly. Bye for now. The problem I have, of course, with working on the Grundig SVR 4004 is the schematics I've got are really low quality. I could really use some better quality.
Priority delivery.
Oh, what's this? From Germany. Excellent. This might be what we need.